You Inspire has connect us and bring us together to contribute for disaster risk reduction and climate change by utilizing science, engineering, technology, and innovation.
Good afternoon, everyone. Welcome to the fourth Chocolate Talk DRR Risk-Informed Decision Making. Also, this is a special session because You Inspire Alliance is celebrating 2 years anniversary this September 2021. We would like to first invite Mr. Aldito Kodijat, Head of Disaster Risk Reduction and Tsunami Information Unit, UNESCO Jakarta Office, who has been supporting UNESCO You Inspire Alliance since its establishment. Mr. Aldito, floor is yours for your special remark.
Yes, thank you very much, Sachi, and thank you very much to everybody. It's very good to see all of you again. And I'm very honored that I was asked just to give a brief remark related to the second anniversary of the You Inspire Alliance. So first of all, congratulations. It's already 2 years. So usually if you are 2 years, you are already walking by yourself. You already be able to walk by yourself. You start to become more talkative, and that's what we are hoping, that now You Inspire becomes the voice of You Inspire Alliance, and all the You Inspire national chapters will be heard globally. So I'm not going to talk about the. I think we will hear a lot about this risk-informed decision making. We have 3 prominent speakers who will talk about that. I think that would be more appropriate for me not to really talk about that. I'm just going to really say that it is still fresh in my mind when we have the meeting after the SIAP activity in UNESCO Office Jakarta. I think there were 8 national You Inspire national chapters at that time which signed the Jakarta Declaration, forming an alliance, and it was really a good momentum event, and the starting of this strong alliance. And then I think it is also I was also very impressed when the member of You Inspire Alliance basically discussed about the governance of the You Inspire Alliance in Chengdu. And that's basically, we just see the video showing how actually the alliance is being governed, involving all the national chapters. So the national chapters is always on board on this alliance. So, and in this anniversary, I would like to appreciate the leaderships of all the officials in the You Inspire Alliance, who despite of the pandemics, were able to actually continue the momentum of You Inspire Alliance. It has been a very difficult time. It has been a very, there are a lot of limitations. However, the You Inspire Alliance officials, as well as the Secretariat, were able to actually convert these challenges into opportunities. And we see this chocolate talk on DRR is one example of basically changing the challenges, the limitations into an opportunity. And I congratulate that. And I think there are many others initiatives, including the response of the youth to COVID-19. When I was asked to give a remark, I actually listed more than 5 items that I would like to talk, but I think that would be fits. Maybe we should arrange another meeting between the Secretariat and UNESCO. But there are 2 main messages that I would like to convey. First, You Inspire should be the lighthouse that have actually give a bright light that become a beacon for the youth and young professionals in Asia and the Pacific, to help them navigate in the sea of science, engineering, technology, innovations for disaster risk reduction and resilience. So I think, again, U-Inspire needs to be this lighthouse of bright lights as a beacon. The second, U-Inspire should also be the powerhouse. So in addition to the lighthouse, it should also be the powerhouse in terms of to continue to empower, to continue to strengthen the Asia Pacific youth and young professionals, to really continue to encourage them to use and to contribute their science, engineering, technology, and innovations for disaster risk reductions and resilience. So I think this lighthouse and powerhouse should be the directions of where U-Inspire Alliance should go. So maybe that's what I can say. I don't want to take too much time. It would be very interesting to listen to this risk information decision making. So thank you very much for this opportunity. And again, congratulations. And I always wish you good luck in the future endeavor of this U-Inspire Alliance. Thank you, Sachi.
Thank you very much, Mr. Aldito Kotisha. Thank you very much for being always a great mentor and supporting us always. As you mentioned, I hope the U-Inspire Alliance will be a lighthouse and a powerhouse. Thank you for your key message. So now I would like to move on to the session. We have 4 speakers for today, and we welcome you to post any questions to the chat box. We will try to follow up after the presentations. And first, I'd like to invite a prominent speaker, Dr. Basanta Rashi Adhikari from Department of Civil Engineering, Pulchok Campus Institute of Engineering, Tribhuvan University, Nepal. Dr. Basanta, the floor is yours.
Thank you, Sachi. Can you hear me and see my slide?
Yes.
Okay, cool. So thanks for inviting me for this auspicious occasion of Inspire Alliance. You know, I know this institute, this initiative since the beginning when you guys started to form this institution. And so currently I'm working as a national advisor of Inspire Nepal as well. And very happy to see colleagues, known faces virtually also. And thanks, Adito, for your wonderful remarks, and which already, you know, set up the stage. So, you know, as you can see that I'm going to talk on geohazard investigation for risk-informed decision-making in the Asian highlands, so mostly in the Himalayan region, where we are facing lots of problems in the Himalayas, you know, including natural hazards, also anthropogenic activities caused hazards. So basically, as I always say that Nepal is a supermarket of natural hazards or disasters. So virtually except tsunami and volcano, you find everything here in this zone. So, you know, to understand this phenomenon is quite important for decision making or policy making. And as you know, or you might know, we have formed the Disaster Risk Management Risk Reduction and Management Act in 2017, after a long struggle with the parliamentarian to understand these disaster risks and how to integrate this to our system. But it still is a long way to go, because things are segregated and dispersed in different parts of this region, which has to be accumulated for combined decision making. So when you talk about these geohazard in the Himalayas, mostly this strong monsoon from June, July, August, September And then the long dry winters are the most triggering or the contributing factors for these geohazards. And as you know that Himalaya is a seismically active zone, which is the young mountain in the world. So we have lots of tectonic activities. So that's why we always call that seismotectonic activities in the Himalayas is like a dream for seismotectonic scientists to come and see how these things are, or these faults and thrusts are moving there. So the seismic destabilization, climatic extremities, for example, the extreme rainfall, cloud burstings, and the thawing action of permafrost, forest fire, and anthropogenic activities. So these are the major causes, So when you see this, let me show you the pointer here. Okay, so when you see this whole Himalayan chain, so Nepal lies in between, but today I'm going to take some examples from Nepal and India. So a few months before, we had a very strong event in Chamoli in India, where we had a rock fall, and that is, that fell down and then triggered the whole mass of ice and debris flowing to the downstream and, destroyed the hydropower. And then you see the many people lost their life and lots of infrastructure had damage. And basically, this is one of the excellent examples of cascading effects in the Himalayas, where people should understand the relationship between one event to the another event, how the magnitude and intensity amplified over time when one hazard triggered another hazard. So this Chamoli earthquake actually is the recent one, but this is not the only one. In the Himalayas, when you look from the past history, in medieval time, like 800, 900 years, people had a similar event in Nepal, Himalaya, and that formed the beautiful valley, what is called Pokhara in the western Nepal. But in 2012, we had a similar event, actually, like in Chamoli. The mass, actually the rock mass has fell down and the partially blocked the river. Also, it triggered the accumulated debris in the upstream of the river, which flowed downstream. And you can see this is the debris of that time, which destroyed many lives and properties. And we lost more than 72 people on that time. And actually, when you analyze this event, this is particularly important in case of Nepal, because most of the civilization started along the riverbed. So people has to understand these things while preparing these plan and policies for a national context, understanding the holistic scenarios of this multi-hazard chain, especially focusing on this geohazard scenario. And recently, we had another debris flow in the central part of Nepal, where you can see that actually the mass has started to move down from here and then partially blocked the river, and you can see it had destroyed the whole village. So, and then just upstream from this village, there is a hydropower, which is the lifeline of Kathmandu for water supply, which has more than 29-kilometer tunnel, and it destroyed all the intake construction activities over there. And you see that the activation of mass, which was deposited, I guess, I'm not sure, which was deposited in Quaternary period, and then probably the cloud bursting or the combined effect of cloud bursting and the weak zone developed by 2015 Gorkha earthquake, this mass was triggered. And in geomorphology, what we call nick point shifting, when you have a gravity pull and then the discharge, then the nick point has been shifting from low altitude to the high altitude. So in other sense, the nick point has shifted to the upstream in the Wematang area, which triggered this whole mass. And then I guess 5 to 10% of the mass has already moved down, and you can see the devastation, the extent of devastation, and you see the drone image taken on that time, which shows that the bank cutting was enormous. So not only the landslide mass, but also the bank cutting. So the people has to understand this combined effect along the river corridor, and then these local communities and the local government, because after the federalism, Nepal has a 3-tier of government. So the federal government, provincial government, and the local government. So the local government is the prime body for now to implement all these activities. So this information has to be integrated into the decision making, informing the possible risk scenarios, doing the risk modeling. So after these 3 prominent examples in the Himalayas, what we can see that this is all the cascade effect. This is the truly cascade effect. When you see the ball and then it hits, when the ball hits this one, then it starts to roll down. And these kind of activities is very, very common in the whole Himalayan chain, starting from Pakistan, India, Nepal, and Bhutan. So this is one of the major challenges and also opportunity to understand the mechanism. So after understanding these things, when you do the planning, when you do the risk modeling, there are different examples and different model you can talk. So one, you can see this is the global climate model conditions. You take the models defined by IPCC, and then you need to downscale these models, and you have to combine this model for the hydrological analysis, for example, surface or rainfall surface runoff, or the three-dimensional modeling using the different softwares. And then you need to inform people for decision making, what we call future climate projections. And then we need to plan our activities accordingly. So this is one of the examples that what we need to do in the future for our better future. So these are 3 important things for the risk informed decision making. One is understanding the risk level. So most of the time people, they talk only about hazard. They often forget about risk, because there is in between then one thing which is called vulnerability, and this is very, very important. And this is dynamic. Vulnerability is dynamic. So we need to understand these things while understanding the risks. And then the risk avoidance during the risk reduction. There are some possible explanation and examples what we can look every day in our life. And the most important thing is understanding the consequences of the possible future scenarios. What would be the scenario when certain kind of phenomenon would happen. So these 3 things, when you understand, then it would be always important for understanding risks, and then you can inform to the policymakers. So what needs to be done in the global context, taking examples from the Himalayas. So let's see some of the points what I'll discuss here. So for example, the problems in the Himalayas, they wouldn't have lots of hydrometeorological stations in the high altitude. So we didn't know what the actual weather condition. So when you talk about the cloud busting, but we didn't have information from the ground monitoring stations. I mean, also we can rely on some satellite images or the satellite data, but ground information is always important. So the second one is the multi-hazard risk assessment, considering the cascading impact. So we have to consider all the possible hazards, not only one single hazard, to understand the whole systemic risks in the changing climate. So another one is the most important is monitoring and threshold calculation for all the warning systems. So for the landslide, for the earthquake, the floods, the lightning and drought, so many hazards that are occurring in our region. This is very, very important. The another one is what we call impact-based multi-hazard forecast system. And early warning forecast is one part of early warning, but what we need to do is the impact-based multi-hazard forecast. And this is the important part we are basically working on with different academia, government institutions, and other things. And at the last, we need to implement the risk-sensitive land use planning, considering all the possible risk scenarios. And then we need to tell our planners and the policymakers, okay, these places really is in risk from the different multi-hazard scenarios. And so that we need to avoid these places for future planning, or this is the safe areas with constraint and non-constraint for the land use planning. So this is the overall understanding we need to do for risk-informed decision making. So I stop here. Thank you very much.
Thank you very much, Dr. Basanta, and thank you for making it very clear that risk-informed means that risk, which includes vulnerability, not only hazard, and also thank you very much for explanation of the cascading effects, and also it is important to inform possible risk scenarios. Thank you very much for all those important points. Now I would like to invite Mr. Abid, I think you're okay. Thank you so much. Next, I'd like to invite Mr. Pradeep Katiwala. Thank you very much, Dr. Basanta. So he is a chair of the U-Inspire Alliance Assembly, and he's the founder and the executive director at Youth Innovation Lab, a nonprofit that works to bring science to people and policies through innovation. And he leads technical development of Nepal's BIPAD portal, government and the official COVID-19 portal. He is alumni of the International Visitor Leadership Program 2017, and on the topic of youth inspiring leadership and civic participation. Mr. Pradeep, the floor is yours.
Thank you. Thank you very much, Sachi. It was a pleasure hearing Dr. Basanta earlier. He is one of the, inspiration for U-Inspire Alliance, U-Inspire Nepal, and to the, very prominent group of young people actually working in Nepal. So apologies, probably you might hear some background noise from my side and also some disturbances. I'm somewhere stuck at the Turkey right now, so probably there might be some technical error. But then, my core of today's presentation is how we can use technological tools for data-driven risk communication. So I'll be stressing with some of the work that we have done in different levels. As you hear before, Nepal is the supermarket, if I can borrow that word from Dr. Basant. So he said that Nepal is a supermarket of many disasters, and this is the example. This is the different kind of events that actually took place in a year in different locations in Nepal. So you can see the frequent number of events happening all over the country. So you can see, except few areas, like all of them are either red or blue or dark blue or indifferent, and it represents each incidents. So this is the portal that I'm showing, developed by Government of Nepal, Ministry of Home Affairs, National Disaster Risk Reduction Management Authority, who is the lead agency to actually look into all these things, owns this system. And this is developed by the initiative of Government of Nepal, bringing all stakeholders, government stakeholders and technical expertise within the government. And we were also one of them to support to the government. And this is hosted in the government server. One of the unique, like part of this portal is that, and portal as well as the act and policies of government of Nepal is that they have specifically mentioned about harnessing open data and leveraging the open data from the global practices. So that actually is a very like progressive thing we can see in context to Nepal. So this portal has, this is the integrated disaster portal. This has 6 modules. So as you can see, it has dashboard where you can see different kind of alerts. It has incidents where you can see post-incident data sets like the one I showed you in the earlier slide, damage and loss, where you can see the number of people died or infrastructure destroyed or livelihood, like impact or other things as well. So you can get in details, and you can also download those data sets. And you can also see some of the data sets of real time that is available there. That may be the pollution or hydrology, meteorology stations, or any other data sets, near real time or real time data sets you can see, find over there. Definitely there are, lags, and also, there needs to be different, stations to be installed in high altitude, as Dr. Basant mentioned. But then, you can see at least some level of data sets in a real time. And also we have profile section that is more focused to the local provincial governments, where you can see a lot of data sets like the record of DRRM projects based on Sendai framework, and also a repository of DRRM related documents, contact informations, and also activities and other informations. And also there is a section called Risk Info, where you can find the hazard, vulnerability, exposure, capacity and resources, and climate change data sets in one portal. So this is something you can see everything together. As I mentioned earlier, this is developed in open source technology. So open data platform data can be readily available to use by any agencies, especially to the people who actually want to research on this supermarket. So you can actually download these data sets in any format that you want, and actually you can do a lot of analysis. So definitely we need more scientific community to be engaged, to actually enrich these data sets, and also to actually understand what could be the better way to communicate risks and mitigate through different mediums. So this is totally developed on open data policy and open data approach. So some of the things which you can see, what we have done is we have overlaid OpenStreetMaps layer. So if you are not aware of OpenStreetMap, then it's an open data portal where people like you, I contribute these data sets, like the one you can see on the pictures, where you can see bridges, you can see the building footprints, you can see the forest cover, land cover, and other details. So these informations are basically validated by the people like you and I through the different mediums like fellowship programs, and there are lots of other ways through which government are doing in their way. So we also run this program called Disaster Risk Reduction Fellowship, so through which we do the placement of young fellows at the municipality for 5 months. And what they do is they actually digitize data sets, and they actually validate this information. And also we do this remote validation. Remote validation means validating certain area through the involvement of young people like us. So this is one of the tasks we have done, the validation that really represents the total validation of that place. And also we can see, who are engaged on this validation and what are the elements validated on this location. So particularly our focus will be to improve data sets through spatial analysis, but then there is also a field-based approach through which we collect data sets and we enrich data sets from the ground. So this is one of the way, where we have overlaid the flood inundation of 2017 on top of the detailed map. So you can see some portions being inundated, some house areas being inundated by the flood of 2017. So these kind of data sets, this is only the exemplary, but then you can figure out what are the potential hotspots, and there are a series of data sets of that particular location, and you can see in which year the inundation was repeated, or you can analyze in different ways as well. So this is one of the examples, and also to actually communicate risks, we have simplified the process of for the risk communication. This is one of the approach we have developed recently. Dr. Basant, he was also one of the key person to actually suggest us, guide us in this process. So you can see, the kind of data sets being visualized in a very interactive way, through which they can understand the land cover, demography, house footprints in different domains, and also the infrastructures, incidents, landslide inventory in different phases, like after earthquake, what are the changes happening in different locations. So you can have all those informations over here. And these data sets were not, developed by this portal itself. So this was brought together by the different communities, something through the engagement of young people, through remote mapping. Some of them were collected from the ground, and some of them through the scientific community that were involved to actually collect these data sets. And as suggested by the previous presentations, we are also working on impact-based forecasting. So this is probably a very new and innovative approach through which you can forecast 10 days lead time along with the risk score of that particular place, and you can see what can be the potential impacted areas. This is in demo version right now, but hopefully this will be developed further. So I'll also stop here. This is just to excite you and to show you that where we are moving with the help of open data and open data approaches. So I'll stop here. If you have any questions, I'll be happy to follow up on that. Thank you.
Thank you very much, Mr. Pradeep. And it was indeed exciting to see all those nice visuals, and then your work. It's a very great example how youth can contribute to this open data development, collection, and also the dissemination. And then visual has a very strong impact, I guess. Thank you so much, Mr. Pradeep. If you have any questions, please post on the chat box. Now I'd like to move on to the Dr. Lanit Chatterjee. Unfortunately, he's not able to join with us, so I'd like to introduce his presentation through the video he already recorded. He is a co-founder of LICA and also ILDR Young Scientists, and a SEM member, UNDRR, and IUCN advisory group member. He has a lot of engagement internationally on disaster risk reduction. Now let me share the videos.
A very good morning, good afternoon, and good evening to all of you joining from different parts of the world. I'm Lanit Chatterjee, and today I'll make a presentation on the disconnect in the global trends and local actions for risk-informed decision-making. Risk-informed decision-making is a very important aspect of the paradigm shift from a response-centric disaster management to make the system sustainable and resilient. It is important that the risk is integrated not only into the system design, but also as part of the decision-making process, which results in the output that comes out of this whole exercise. And to understand how this decision-making process happens and possibly which are the areas which still needs a certain amount of what do you call support, is what I'm going to talk about today. So for an effective risk-informed decision-making process, there are a few points that are possibly important. But before we move into it, I think it's also important to understand what is risk-informed decision-making process. Risk-informed decision-making process is nothing but if we are able to understand a risk, or are we able to understand a future risk, or possibly something which we already have experienced in the past, and that kind of an risk, once we integrate into the final decision, that helps us in reducing the uncertainties or the lowering the probability of failure. And that's possibly the one of the easiest way to inform why risk-informed decision-making is important. So in order to do a risk-informed decision-making, there are 4 important factors. One, of course, we should know the risk, which is more fact-based or either based on the probabilistic modeling. Then, once we know the risk, we have to possibly make a decision which risk is acceptable and which is not. And these are more value-based. Once this decision is taken, then there is certain other aspects which comes into play, like whether there is a cost attached to it, what would be the future impact of this, and these are possibly something which are brought in looking at the broader impact of this decision-making process. And once this decision is made, possibly the 4th step is monitoring and evaluating how that decision is making right impact, or possibly if there is a need to make a change to the decision-making process. And that becomes a very critical aspect of this whole risk-informed decision-making process. And it's an iterative process. So there is possibly, we can say that there is no right decision, or wrong decision, so to say. But what we have is possibly the most effective decision at that point of time with the given data set that we have. And on your right hand, if you see, there is this interesting figure which shows that possibly there are 2 important processes in this decision making. One is the execution quality, the other is the decision quality. And the zenith of this on the 4th quadrant on the top, you can see that that's where possibly the risk-informed decision-making process happens. So where the execution quality is the highest, as well as the decision quality is the highest. And that's the most effective form of it. So, as I said, there are possibly 3 important factors which leads to a effective decision-making process. One is risk. The second is the strategy or the decision that we are taking. And the third is the performance, the outcome of it. And when we start, this is basically a phased kind of an approach where these 3 are there in a space. And mainly what we try to start with is linking risk to performance and also linking performance to the strategy. That's the second phase. And that gives an overall idea about how things are shaping up. Then the actual or the ideal state is where we link risk, strategy, and performance. And that's where possibly an effective decision-making process will happen. So this is just how different phases of a risk-informed decision-making process actually unfolds on ground or in reality. So if we look at this whole process in a bit more detailed way, it's possibly there are two approaches to this knowledge base or the risk knowledge base, if I would say. One is evidence-based, which is based on real-time evidences or past experiences. The second is probabilistic modeling or futuristic risk estimations. And these both are important to add to the knowledge base. Then, based on it, we do a very broad risk evaluation to understand how this whole risk is located within the environment or the global scenario or regional scenario or local scenario. And there is also this component of acceptable risk and non-acceptable risk within this. So within the broad risk evaluation, we look at the various acceptable risk and non-acceptable risk. And then it is communicated to the decision maker. And this first three stages possibly is more with the risk assessors, experts, scientific community who are more involved in it. And these are more fact-based, or you can say more on the statistical aspects, or it can be also qualitative data, but more, I would say, fact-based. In fact, is both, which can be validated. The second part of it, once it moves on to the decision makers, possibly again, kind of a flow chart happens where we look at the acceptable risk, non-acceptable risk, which is possibly, and there is also this concept of tolerable risk, which is a bit different from acceptable risk. And then a decision maker would, based on the various factors, make a final decision. And this whole process is value-based. It also relies a lot on the past experiences of the decision maker, on the gamut of all the other impacts that might possibly happen because of such a decision. And this is where possibly we are talking about the risk managers who are making a decision and to implement it on ground. So that's where possibly after the decision is made, and monitoring process is also required to see that how effective was the decision, and whether there are critical nodes which needs to be revisited and changed to make that decision increase the effectiveness of that decision. We just take an example from this status of priority of actions in Asia Pacific, the Science and Technology Status Report. And we see, if we look at this priority of action 1, 2, 3, 4, possibly when we talk about risk-informed decision-making process, it applies to all of them, but more to action 1 and action 2, where we are talking about understanding risk and also risk governance. And we see that a glaring gap possibly is there with the data and knowledge base that is there to support the decision-making process. Also, monitoring and review or monitoring and evaluation processes which are needed to look at how this understanding risk is unfolding over a period of time, how it is getting incorporated into the decision-making process. And you can see that possibly priority action is the one which is still falling below average, except for capacity building, which a lot of capacity building exercise has been done. But then on the other hand, if you look at priority action 2, which is more on risk governance, possibly that's where more of hand-holding needs to be done for capacity building. And why this kind of an, why there is still a gap in the risk-informed decision-making, especially when we talk about, global trends and local actions, is possibly the data gap. We know, like, many global trends have been researched. There is a lot of scientific research that are being done. Say, for example, the global climate models are there, and those or regional climate models are there. But downscaling those models to inform the local authorities or communities who are getting affected, possibly that's where there is still a gap, and that kind of a local data data is needed. Also looking at communication failure, many of this, when we talk about different stakeholders, they have their own language of speaking, and many times effective communication happens when one party understands the other. What kind of language are we using? How, because possibly someone working in the scientific community would be more interested in communicating in their own language, but a decision maker would like to understand what are those points which they want to take up for making a decision. So it's not that whole gamut of findings needs to be communicated. So we have to be a bit mindful, and that's where possibly a lot of work needs to be done. Knowledge and skill gaps. I have worked with a few of the local authorities in India and also outside India. And one of the major setbacks as of now for the local authorities is having dedicated team to work on disaster management or climate change, and also the skill set available with those human resources. So that's possibly a gap, and which is a problem in integrating this risk-informed decision-making process into local action. Also, along with it, there are funding gaps, especially at the local authority level, because of cities like class 3 cities, class 4 cities, or small island nations. Possibly there is still a need for funding to support such kind of decision-making processes. At times, there are external influences to make certain decisions. Those can be political, those can be biases, personal biases, those can be some other, for other reasons as well. But there are those external influences which influences the risk-informed decision-making process. And that's an area which possibly still needs to be needs a lot of studies to come in and show that how such external influences can be reduced. And finally, there's also this issue of inclusiveness within the decision-making process. Who is making the decision? What kind of stakeholders are part of it? And how can it be made more participatory to create more ownership among different stakeholders? I think these are few of the gaps which are there to possibly why we see this mismatch between the global trends and local actions. And let me just highlight this with one small example, which possibly would relate to the present on COVID-19 situation. This COVID situation, you would realize that many countries have come up with COVID trackers. And COVID tracker is more designed to track once a person is infected. But what possibly we are lacking till now is a tool or a method or an approach where we can estimate who, or we can see who will be affected. And that is a very important aspect for a policymaker to make a decision on ground that which all areas possibly they want to lock down, where they want to impose more strict guidelines for COVID-19 preparedness, or what kind of action, local level actions, very specific actions can be taken. And for that, we need to know the risk. And possibly that's something which has not yet been done to the extent which is needed. And that's why what we see is reports of only people who are affected. And once someone is infected or exposed, possibly that's not something where we as disaster managers can come in and try to prevent the spread of the infection. So this is, I'm just giving you an example which I had worked on this COVID risk assessment tool, and where we tried to crowdsource this risk assessment or evaluation, you can say, as a quick risk evaluation on who can be affected based on 4 parameters like health, exposure, behavior, and social policy, how these are happening. Based on it, you can have a quick estimation. You can see which areas, because once people start taking this, risk assessment, it starts populating on the map, and you can know that which all areas has a higher probability and of people being infected, and then the policymakers can take accordingly some preventive actions or mitigating actions. And this is also important, not only to make it a tool, but also to validate it, validate the process. We also have published the approach, and you can see, if you are interested, you can see this paper. So this is possibly an example of how risk-informed decision-making process can aid decision makers. But again, there is a gap in how this will be utilized by the decision makers, and it will vary from one place to the other, one decision maker to the other. So coming to the end, possibly, of this presentation, we look at what are the possible way forward. And one very important thing, we talked about data gap, and that's something which has been repeated again and again. There is data gap, there is data gap. But what needs to be done? There is data available. It's not that we need to create new data, but what is important here is to create new methods and approaches for data collection that is there, that is floating around, that is possibly there with very different stakeholders. The second important thing is inclusive approach to bring collaboration and ownership. And one of the examples is like in having citizen science as part of it, or think about how to bring in private sector, which is much more effective in reaching out to the community, to the end consumers. And that's a very important aspect of this risk-informed decision making, to how to bring in all the stakeholders on board, utilize their expertise in understanding risk and also making informed decisions. The third important task is risk communication, and how to bridge this language barrier, how to bridge the problem of, or the hiatus that is there between experts and decision makers. Can we have a common language where we understand what we want to communicate and also what we want, how that risk is transformed on ground. And fourth, and very important aspect, especially when we talk about local action, is to create awareness and training of decision makers at and that's possibly which needs to be integrated into academics, into the various trainings which a young bureaucrat would receive when they are starting at their career, or at the municipal level when the staffs are recruited. Possibly that's where they need to be trained to appreciate the scientific data, how those data can be transformed into decisions. And that's, I think, will pave the way for a sustainable world through a risk-informed decision-making process in future. With that, thank you all for being with me today. And if you have any queries, questions, please feel free to write to me. I'm really sorry that I couldn't join you in person because of some personal commitments, but I would like to hear from you. Thank you.
Thank you very much, Dr. Ranit, for your videos and also introducing the sequence of risk-informed decision-making, and it highlighting also the gaps and the way forward. I guess it also helped understanding of what other presenters mentioned. So finally, I'd like to introduce the fourth speaker. So I'd like to invite our Secretary General of the U-Inspire Alliance, Dr. Nurani Rahma Hanifa, who is a founder of, and also the first lead of You Inspire Indonesia as well. And then she conducts several interdisciplinary research on geodynamics, earthquake, tsunami, and disaster risk reduction, and engages in community service and bringing science to action and policy. She's also a member of AP staff of UNDRR. Dr. Rahma, the floor is yours.
Thank you very much, Dr. Sachi, and thank you very much, Pak Ardito, Dr. Basanta, Pradip, Dr. Ranit. All are very insightful presentation and very motivating. Maybe let me share my experience on bridging geoscience to risk-informed decision making. Based on what I mostly do with the National Center for Earthquake Studies, and also together with You Inspire along this way. So I currently work in the Indonesia Institute of Sciences, which from this September become the National Research and Innovation Agency of Indonesia, or BRIN, under the Research Center for Geotechnology. So maybe in my talk, it will be more focused on earthquake and a little bit of tsunami, because that is where my expertise and also my experience lies, and why this is important, why it motivates me on earthquake. It's because looking to the statistics in the last 20 years, even in the last 100 years, earthquake has caused a major loss in terms of lives, loss of lives, and also economic losses and infrastructure damage. So all of the, if we have 7 targets for Sendai framework for disaster risk reduction, the 4 of those targets is to reduce the mortality, reduce the infrastructure damage, reduce the economic loss, and reduce the people affected by disaster. And in Indonesia, we have caused, in statistical radar in the world, we have lost a lot of lives and damages due to earthquakes, especially when the earthquakes is followed by tsunami. Most of this, including in Haiti, is also caused by earthquake. Pakistan, India, Sri Lanka also by earthquake and tsunami, and in China as well. But we can see in Japan, even though Indonesia and Japan have a little bit similar of level of activity, but Japan can live more in harmony, even though Japan as of now still reach 0 fatality. So that's what motivates me, and because Indonesia is also located in the Ring of Fire, we have about 22,000 earthquake every year with a magnitude more than 4.5. And when we were engaged with the National Center for Earthquake Studies, we have mapped in 2017 275 active faults, and these active faults meaning the active faults that has happened that slipped once in 10,000 years, and also the source that is capable more than magnitude 6. So if we go for more detail and more smaller active faults, we will come up with more numbers of active faulting. And we have 13 megatrust segments. And when we overlay with the population of Indonesia, we got that 77% of Indonesia population can experience earthquake with intensity 6 or more, so more than 200 million people. And in Indonesia, we are still struggling to live with intensity 6, even with intensity 5. It's still a lot of homework for us to also stand with earthquake with intensity 4. And among those 2,000 million, we have 4 million people that lives directly above the active faults, and 90% the megatrust earthquake and also the faults that goes through the seabed also cause the tsunami disaster and also some landslide. So when we talk about this risk informed, of course, the first step is to understand the risk itself. And for the framework based on the global assessment report from GAR. This risk informed is also for sustainable development. And this risk is consists of understanding the hazard, understanding the exposure, and understanding the capacity. We have this to connected to the Sendai framework, to the 2030 agenda, Paris Agreement, New Urban Agenda, the Agenda of Humanity, and also the Addis Ababa Action Agenda. So this is for also to support the Sustainable Development Goals. So we actually see from our experience, this national Center for Earthquake Studies was established in 2016 after the first national map in 2010. So we find that there are many research that need to be compiled and to be documented for the purpose of the Ministry of Public Work and Housing to build a better infrastructure. So the Ministry of Public Work and Housing actually need a unified map, hazard map, source and hazard map for them to build a better infrastructure. But this map is also used by a wider audience, national, local stakeholders. And for example, once after we launched the 2017 source and hazard map, it was used for developing the master plan for disaster risk reduction of Indonesia in 2045. And then it's also one of the important input for conducting earthquake risk assessment and mapping based on the our National Disaster Authority regulation that the input should come from the National Seismic Source and Hazard Map. And then after this this map, we have also, it has also be the basis for the national standard for earthquake resistance building and infrastructures. It has developed about 8 national standards and still updating and develop until now. So it's we have more than 8 is currently developing. And now that our government is also more keen to link with a better spatial planning based on this map, and also been used for contingency planning. But for contingency planning, we also need to first use this source and hazard map to conduct the risk assessment. And after that, from the risk and impact assessment, it is used for contingency planning. And we also use this map as a basis for mitigation preparedness in schools, hospitals, energy powers, and so on, and for updating the education material, and also as a basis for community engagement. So actually this currently we are trying to bridge all the geoscience product to the risk-informed policy and also action. And how are these geosciences in this development of seismic sources? So the geosciences part is actually come from, at first, when we want to understand the source and hazard map, we need to understand the earthquake source and characteristic. So the earthquake source and characteristic is actually developed from 3 disciplines: geology, seismology, and geodesy. So I am part of the geodesy working group. And then once we can understand the geological source, and then from geodesy we can understand the slip rates and the movement, the tectonic, and come up with the slip rate as the basis for the input for the characteristic. And also for the seismology, conducted the relocation, and also as the input for the characterization of the earthquake source. So understanding the source and characteristic is important first phase for developing all the other documents behind this. We need to understand the ground motion equations, which needs another discipline, and then understanding the response spectra and the ground motion, the amplification from the bedrock to the surface. And from all of this, we can understand how is the hazard map, and then we calculate the risk. Once we get the exposure, geospatial exposure, and also the vulnerability, the fragility curve, and also multiply by the capacity. So this is all the ingredient and inputs to the policy, and also to the communication, to the community action. So sometimes the policymakers also need to understand all of this process, because the geoscience itself is always developing. For example, this was my dissertation for the part of understanding the potential of megatrust beneath Java Island. So this is Java Island, this is Jakarta, and this is my city where I live in Bandung. So we currently have the GPS, maybe you use in your handphone, and we have the scientific GPS. We can have resolution until 0.1 millimeter. And from this, we can, if we understand how the tectonic is moving, is the form, we can understand and model by using inversion method, how is the energy is accumulating beneath our island. So that is the basic concept, and we need to understand this kind of science, and understanding this kind of science also need a high-tech technology and high-tech computing. So from this, we need to also understand what will be the impact. So we need to also understand for megatrust case, for example, we conduct the tsunami modeling to understand how from this source, how it will trigger how it will move the megatrust plate, and how it will move the ocean beneath, and how it will go to the shore. And this is what we are newly trying to understand, is utilizing drone mapping and UAV mapping to obtain a more detailed exposure data. And then we try to model with the tsunami, so we understand it provides a more clear understanding on what will be the risk of the megatrust. So if we just say, for example, okay, we have a potential of megatrust 8.7 or 9 in South of Java, the policymakers or maybe the community need to retranslate what will be the impact. So we need to do the impact modeling or the risk modeling and impact modeling. So then it will trigger more for policymaker to be informed what will be the risk and what action need to be taken to reduce the risk that might happen to their location. So to conduct all of this, we really need a multidisciplinary collaboration. Only scientists will not be able to do the risk inform, but from understanding the risk information, we also need to come up with the standard and guidelines, the performance measurement, the infrastructure policy and planning, and also we need to engage with the users, with the communities, with research institutions, with sectoral ministries. It's very important to connect with sectoral ministries and to explain to them and to work with them. Also with local government agencies, with private sector investors. We also have problem that sometimes is not only the constructor, but also the owner don't understand how to also include the risk-informed building. So how to also elaborate the earthquake or tsunami or other disaster, so they can have more sustainable building and businesses, and of course professional association. So all of this will also need a better knowledge production and management interface, which we are still lacking in Indonesia. So many of knowledge is spread, and it's a little bit difficult to translate and to compile of the knowledge that is already exists to make one policy brief and to translate into a policy maker. So I think what Dr. Mizan, who's supposed to also share today, but he is sick, so he cannot share what he's doing on this, all the knowledge management has been a very important work for the development of risk inform. So I will also show one case for after Palu earthquake in 2018. In Palu earthquake 2018, we had an earthquake of 7.4 earthquake in so-called Sulawesi area. And this earthquake, if you see in the picture below, so this is the bay of Palu Bay. And then the earthquake rupture 75 kilometer and passing the Palu city. So when it passed the Palu city, the surface deformation is as large as 5 meters in average. Some is larger, some is smaller. If you can see in the figure below here. So this is the 5-meter dislocation of the Palu earthquake. And then we have, because this strike slip faulting goes through the bay, the tsunami come very fast, less than 5 minutes, and it washed away about 200 meters. So this is example of schools. Many are washed away near the shore, but actually only about 200 meters or until 500 meters. The head was 3 meters, but because it happens during the Palu City celebration, and the Palu City celebration took place on the bay, and there was no direct evacuation route. So many people were trapped in the bay and was devastated, was killed by the tsunami that come just 5 minutes after the earthquake. And then we also have a very massive flow liquefaction, which we cannot imagine. It flows about 1 kilometer away, and many houses was fallen by this massive liquefaction because it has some slope and it is just in the border of an irrigation channel. So we have this blue dots where the location where the massive liquefaction happens. So after this, the government need to rebuild, and rebuilding Palu was very difficult because all of this complexity. We were deployed the National Center for Earthquake Studies for mapping the faults and also the location of liquefaction and also the tsunami hazard, the tsunami inundated area. So the government decided to make those area as a red zone because it's very difficult to do the engineering or to live within those kind of area. So it is assigned as red zone, and it took some time, and several about more than 8 agencies, ministries were involved along with JICA from Japan too, to map all these red zone and also divide into the orange and yellow zone to rebuild the Palu. But then within the process, the COVID-19 occurs. So the rehabilitation and construction process is also a little bit slower in Palu earthquake. So until now, some are still living in the temporary shelter in Palu, and the trauma is also still there for many people. So it's very challenging for this kind of situation, especially where many of the affected was actually people that comes from Java. So we have an massive migration happening from Java to Palu after our Independence Day. So we also have some challenges for safe schools and other, because we also have many schools that is directly facing the ocean, and only it's directly on the coast. For example, this school, the yard is directly to the sea, and then the quality of the schools maybe in this is in the outer island, yeah. So we have about 17,000 islands, and in those islands maybe not the quality is not so good, and I mean the construction, and also many schools are directly in the coast. So it's also difficult because moving or relocating school is also not easy, even though it is a little bit important to do so. So I think previous speaker has also mentioned about systemic risk. Risk is not only just those three component: hazard, exposure, and vulnerability, but also we have this new knowledge on emerging risk and systemic risk that eventually need to be incorporated to the way forward, because the complexity is very high when dealing with this kind of risk, especially when one hazard can trigger another multiple hazard, plus the complexity of the governance and the capacity of decision making itself. So and the other problem when we want to bridge science to risk-informed decision making is, as Ranit mentioned, often sometimes scientifically it is scientifically accepted, but not politically accepted. So this will make the risk-informed decision making process difficult. But sometimes it can be politically accepted, even though it's not scientifically accepted. We also experience this kind of debates with the government, because finally the political will win again the scientifically judgment. So looking the meeting points between science and politics is a way that is very important, and we find that scientists actually also need to learn such a process, not only the science itself, but also how to bridge science to political will, so we can do this risk-informed decision making. That's from my end. Thank you very much, and return back to Sachi. And happy birthday for UNSPIRE Alliance.
Thank you so much, Dr. Rahma. And it was very strong key message that not only scientists produce and disseminate information, but that has to impact on the decisions of policymakers or like a council actor and community members. So it is very great to see the stakeholder, the circle, that figure you created. So thank you so much. It was great to hear all 4 presentations. I hope you enjoyed very much. And thank you for all 4 presenters who shared us very inspiring talk. And I think all those topics are quite interconnected, and then it provided a really comprehensive idea on the risk-informed decision making. Now I would like to move on to the question and answer session. Sorry, the time is limited, so I would like to pick up only a couple, but please don't hesitate to post in chat right now if you have any questions. But first, I would like to ask a question to Dr. Basanta. There is a question from participants. What kind of models do we need for multi-hazard risk assessment, considering the cascading effects?
Thank you, Sajid. This is really interesting question, and this is evolving in science as well, because we didn't have a straightforward answer. Because as I told you before, that the vulnerability is very, very dynamic, and it's very, very localized. And the vulnerability consists of social, economical, environmental, and physical. So these 4 elements are different from place to place. But there are some models, and particularly for recently working with USAID Nepal, I have developed one model which is based on multi-criteria evaluation. But still, when you talk about the cascading, then I developed for 2, for example, landslide and earthquake. But I'm facing problem now defining landslide triggered by earthquake, dam the river, and trigger the flood. So it's evolving, and it's a very good question by Kshitij, and I hope we work together to develop this model. Thank you, Kshitij.